Hi everyone, welcome to Open Source Spotlight. In Open Source Spotlight, we invite open source authors and ask them to demo their tools. And today we have Raz. Raz, welcome.
Thank you very much, Alexei.
Yeah, can you tell us a few words about yourself and about the tool you want to show us?
Yes, so my name is Rotenberg. I work at Run AI. I've been here for a few years already. And at Run AI, we build the advanced tools to manage GPUs for organizations. Now, we build it on top of Kubernetes and, like enterprise stuff. But over the time, we realized that many of the advanced concepts that we build for enterprises and for companies, we can also build their community version and give it to the community as an open source project. So it took us some time to understand how we really want to do it and how we want to wrap these capabilities. And this is what we did with the tool that I'm going to show today, and we call it Genv. It stands for GPU Environment Management, and it's an environment management software for GPUs. It's very similar, and I took a lot of inspiration from existing environment management software like Conda, PyEnv, and other software there. And it works in a very similar way. And today I will show how to use it and how we believe that we can provide the community with better GPU management software, which is 100% open source and community backed as well.
Yeah, I'm really looking forward to this demo. I actually have a laptop with a built-in GPU. Laptop is on Windows, and recently I wanted to configure this GPU to train a model on TensorFlow. And it took me like, I don't know, 2 days or 3 days maybe. And I have no idea how I did this and what worked and what didn't. So hopefully, maybe I am setting my expectations too high, but hopefully after seeing this demo, next time it will be like 5 minutes for me.
Yeah, and maybe even if not today, then I'm sure that as long as I talk about Genv with more people that use GPUs, I understand that there is even a bigger need for tools in these areas, and that Genv can provide much more value than I thought in the beginning. And yeah, this is one of them, for example.
Yeah, so let's see. Really excited about that.
All right. Great. So just a sentence before we start. So Genv is supposed to be used by GPU users, for example, researchers, data scientists that use GPUs. And it's also supposed to be used by entire teams that share GPU resources. And I'll demonstrate everything, and I'm sure it will be clear. So let me just share my screen here. So I'm using a GPU machine in the cloud, and I'm going to run nvidia-smi here. And you can see that this GPU machine has 4 GPUs. Now, most of the GPU users that I interviewed, what they do at the first thing that they come to a GPU machine, they try to find a GPU that is not being used at the moment. And I try to simulate here a use case that happens for many users out there, that you can see that there is a lot of information here. You can see all the GPUs that you have on this machine. You can see that some of them are being used at the moment and some are not. You can see the amount of GPU memory that is allocated at the moment. And you can see that there are many applications running on them. Some of the applications even share a GPU. And it's funny, but this amount of memory, of information, this output of nvidia-smi could be even less informative when we're trying to find something specific, like a GPU index to use. So I can look at that and I can see that this GPU at index 2 is not being used at the moment. And now I can go to my application and modify it so it would use these GPUs explicitly. But I need to understand how to modify the application's code, and I need to do it manually. Now, what Genv allows me is to avoid that. It does everything for me. And the first thing that I want to do when I come to a GPU machine now is I want to create my own sort of isolated GPU environment. And I'm going to do it by running this command. It's genv activate. It's very similar to commands like conda activate, pyenv activate, or other virtual environment management systems. Now, once I'm running in an activated environment, if I'm going to run nvidia-smi, I can see that there are no devices. Now, I know that there are 4 GPUs on this machine. It's just that my environment is detached from them. In contrast to when using GPUs directly on the machine, when running in the GPU environment, you need to, it's not manually, because we will see later that it can be done automatically, but the GPUs are being attached in a controlled way and in a managed way. Okay, so now I can say that I want to use this in this device. All right, then I can ask Genv to attach a device in Tix2. And from now on, everything that I'm going to do in my environment is going to use this GPU alone. For example, when running nvidia-smi, I'm going to see information only about this GPU. You can see the GPU index here. If I'm going to run some application, we will be able to see that it's using this GPU, right?
What is it doing? Like Minist?
Yeah, so this is a sample application I created. It's sort of like the CUDA samples that they give you. It's open source. It's just doing some computational stuff on the GPU, nothing really important, but it's just to simulate the GPU consuming application. Any application would work. I could have ran here TensorFlow, Python, PyTorch, tried anything. All right, so let me just shut this application down. And okay, so last time I executed nvidia-smi, I saw the information of the GPU that I'm using. But the truth is that with Genv, I can also configure the amount of GPU memory that I want to be available for their environment. I'm going to do it by this. And I can say that I want to use 6 gigs of GPU memory, right? From now on, when I'm going to run nvidia-smi, I can see that there is only 6 gigabytes of memory that is available for my environment. Now, I can run the same application. I can tell it to use, for example, 4 gigabytes of memory. And now when I'm going to run nvidia-smi, I will see that approximately 4 gigabytes, this is maybe byte, this is why the numbers are different, but I use 4 gigabytes out of my 6 gigabytes. Now, if by mistake, I used more memory, for example, by running this application without specifying memory limitation, then if I ran nvidia-smi, I could see that I'm using more memory than what's available for my environment. And we can see this warning note. And this helps users to actually monitor the resources that their environment is using and their application is using. Now, in addition to that, right, let me just shut this down. Now, if I'm going to run nvidia-smi and I want to see what's really happening, I can pass this environment variable, bypass, and this will show me the actual output of nvidia-smi from the host perspective. Now, I can see that something is running on GPU at index 3, right? And I'm going to show you that right now, if I'm going to run Genv status, I can see that I'm attached to GPU at index 2 only. This is because I requested it. Now, I'm going to ask it to attach to GPU at index 3 as well. Now, I know it's going to fail because it's already attached to another environment. Now, just for now, for the sake of this demo, I'm going to use some of the environment variables that will allow me to do it. Yeah. All right. So right now I attach to the device at index 3 as well. Now we already know that something is running on it, and we can see that some of the memory is allocated there. But if I'm going to run nvidia-smi from my environment, I will see as if nothing is running on it, because nothing from my environment is using resources on this GPU. I can see that there is no processes running on any of my GPUs, and the memory that is available for my environment is available for me to use. And this whole isolation, we believe that it will help GPU users to control and monitor how many resources of the GPUs and memory in particular, how much memory they use. Now, if I'm going to run the same application that I've been running, I can specify, for example, 1 gig. And from now on,
Sorry,
it's
not
going to
both,
use,
right? Okay.
yeah, it's going to use both GPUs. And this is exactly what I wanted. All right, so let me just shut it down. Yeah. So until now, we saw the power of a GPU environment, what it provides you, how easily it is to attach to devices and to configure the GPU memory that you want to use and to control it and to monitor it very easily and very intuitively using tools that people already use, like nvidia-smi, right? But the truth is that the real power of Genv comes when all the users in the system use Genv as well. For example, I can run the command genv-env, and I will be able to see all the active environments, the active GPU environments of all the people that are using GPUs on this machine. I can see who's using, for how long. They can name their environment, for example, with the name of the project that they're working on, and I can also see information about the devices. For example, I can see which environment uses which device, and this will help me to see what devices are being used and which devices are not being used and for how long. And what I'm going to do next is I want to tell Genv to detach from the devices. For example, now I'm going to run Genv status. I can see that I'm detached from GPUs. And if I'm going to run nvidia-smi, it will be very similar to what happened in the first place. Now, I want to remind you that before I explicitly asked for GPU at index 2. And this is because I manually saw that this is not being used at the moment. But actually, the power of Genv, when all the users are using GPUs via GPU environment, is that I don't need to specify the specific GPU index that I want to use. What I can do is I can ask Genv, I can tell Genv that I want a single GPU. This is how I do it. Now I'm going to run the command genv attach. I'm not going to specify an explicit index, but what happened there is that Genv looked for the amount of GPUs that I asked for, which is 1 in this example, and it looked for a single GPU that is not being used at the moment. And I don't really care about what the index of this GPU, because all I want is a GPU. And from now on, I can run nvidia-smi and my application in a very similar way to what we did before, without even having to ask for a specific index of GPU. And this is very helpful when you work with many colleagues or many people that you share your GPUs. And if you have many GPUs, for example, 4, 8, even 16, it's much easier this way. Plus, many of the GPU users, they look at the nvidia-smi and they try to look for a GPU that is not being used. And the way they do it is they look for a GPU that there is no running processors at the moment that use the GPU. But actually, there are some use cases where you don't have a process running on the GPU at the moment, but you do have somebody working on the GPU. And this happens, for example, when you use remote debugging, for example, from VS Code. So whenever you're not debugging, actually, you won't see a GPU consuming process in nvidia-smi. So relying on the output of nvidia-smi can be misleading and could cause to GPU clash between users. And this is the way that the Genv provisions GPU. Now, after we saw the power of GPU environments, and we saw that the GPU provisioning is being done automatically and transparently for the users, all the user needed to do is to configure the GPU environment. We configured the device count that we wanted. It was 1, and we configured that we wanted 6 GB of memory. Now, we believe that the good way to manage these GPU resources for projects is as infrastructure as code. And what I'm going to do now is I'm going to create a directory called .genv, very similarly to what there is with .py, .github, .git, whatever. And now I'm going to see the configuration of my environment. I can see that I configured the GPU memory and the amount of GPUs. And now I'm going to ask Genv to save the configuration. What it did is it created files, and let me show you the content of these files. The content of these files is just the configuration that I configured. And these files, we believe that they should go to the GitHub repository of the project. And they specify the GPU resources that my project needs. And I know it because I created the project, and I know how many GPUs the project expects to see and how much GPU memory it requires, right?
So it should be in the root location of the project, right? Not in your home directory, because you're at the same time in your home directory. And you know, in the home directory, we always have these dot files there. So
exactly.
Here you're talking about the root of the project.
This is a great point. So Genv now supports multiple locations. It's either the current working directory, which is the root directory of the project, and this is the best case. Actually, maybe I should have demonstrated by creating a project directory and then going into the project directory and then show it there. But we also support to have a default configuration per user. For example, if you do place this .genv directory in your home directory, then every environment that you will create will use this amount of GPU memory. Now, it's not only memory, it's also the name. For example, you can configure the name of the environment. It's like I can say that it's my project, right? And I can ask it to save it. And what's happening now is, for example, if I go home and I disconnect from the server, or I just deactivate the environment, right? What's happening now, or maybe if my colleague or myself, my future self would clone this GitHub repository, and then I would enter the directory of the project and I will want to activate a GPU environment, it will immediately and automatically load the configuration, and it will know that I wanted only 1 GPU and 6 gigs of memory, and it already looked for such an available GPU and attached it to me. So all I needed to do is just to create an environment from an existing project, and I have a ready GPU environment that I can start working without fearing that somebody is going to hijack my GPU, right? And we believe that this is where the power comes from, because if every GPU consuming application would specify the GPU resources that the application needs in terms of projects and as infrastructure as code as part of the GitHub repository, it will be much easier to share these projects between colleagues, between friends, among the community, and even when submitting this project to another solutions out there, that they will run your model, for example. Now, up until now, I showed you the core component of Genv, which is terminal-based. But actually, that along this terminal-based software, we have built extensions for common IDEs. And I'm going to show you the extension that we created for Visual Studio Code. I'm running on the same GPU machine. You can see that my VS Code is connected by SSH. And if I run nvidia-smi here, I can see the same information as I saw when I executed in the terminal directly. Now, for example, if I'm using VS Code to work on my GPU project, what I can do now, I can go to the extensions and look for GPU. I can install the Genv extension. And after a few seconds, the extension will be installed. Right now, I can go here and I can have a view of all the environments and all my GPUs on the machine. And I can see which ones are being used at the moment, etc. So let me just go back to the machine, and I want to deactivate 2 environments. And yeah, let's just deactivate this one. All right. I'm gonna refresh, and I can visually see which GPUs are being used at the moment and which ones are free. Now, if I know that my project requires a single GPU, for example, then I can ask the extension to activate the environment right here. Now, I can edit the environment name. I can call it my project 2, for example. And right now, it says that I'm not connected to any GPU. If I executed this Python code, which tried to simulate a Python application, for example, a model that uses GPUs, we'll be able to see that because of the Genv extension, right now, this is not attached to any GPU. Now I can go here and I can specify the amount of GPUs that I want. And in my case, you know what, previously I wanted a single GPU, but now let's just use 2 GPUs, why not? And Genv automatically finds the available 2 GPUs, and I can see that they are turned green right here. And this means that these are the GPUs that are being used by my environment at the moment. If I just rerun my model, I can see that it is attached to these devices. And it's all done automatically behind the scenes. And I can reconfigure it by specifying another number of GPUs, or I can just manually pick whatever GPUs I want to use. Now, this helps users to switch between GPUs without requiring any code changes, and it's done very intuitively using this GUI interface. And we believe that we can provide these GPUs capabilities of Genv in a very native way for every GPU user. And this is why we created this extension for VS Code. We also have an extension for JupyterLab. Let me show you. It looks something like this. You can go try it out. And we are working on building an extension for PyCharm as well. So
that's impressive. Well, it's I expected something else, but this is different, right? So I guess my question is, do you plan to have any, like, because when I hear about virtual env, I think, okay, like this library has these dependencies, this library has these dependencies, and virtual environment allows each library has its own dependencies, so they don't conflict. And I imagine that there are situations like one library has to have like a CUDA of specific version, cuDNN of specific version, TensorFlow of specific version. So does genv help with this, or like is it in the plans?
yeah, that's a very good point, and it was raised by some data scientists that we reviewed. And Ekin is one of my colleagues, and she's a contributor to this project. She interviews many data scientists, and she came up with the idea as well because she's a data scientist as well. And she told me that many times people are having a hard time to understand the GPU requirements of their project. For example, the CUDA version, the driver version, the actual model of the GPU. For example, is it a T4? Is it a V100? Does it even matter? And what we think is that we might want to end up adding here another view, which is of the current system. which will tell you what driver version do you have, what CUDA version do you have, what's supported here or not supported here. And this will also be a part of the GN configuration. You'll be able to specify that you need at least CUDA 10.1, for example. And if you don't have it installed, we can visualize it here and tell you, like, your project might not work well, you need to upgrade your drivers. And yeah, this is something that we're looking into. And another thing that is that we want to bring better visualization of GPU to this extension. For example, we want to show you here what's the GPU utilization, what environment is using which GPU exactly, and how much of the GPU memory is being used at the moment. And maybe you'll be able to see here that you have 2 gigabytes of memory used out of 16 gigabytes, and you will be able to run another environment here. Or maybe in the system area that we will add in the future, you will be able to see what's the average utilization of your GPUs. We believe that when you will have better visualization of the GPU, plus a dependency manager for both GPU resources, like what Genv already is doing, and CUDA versions and driver versions, then we might ease the way that people interact with GPUs. And we believe that everything should be encapsulated and transparent to the user, because the data scientist has enough to keep in mind, right? What you don't want to deal with is the GPUs themselves and the drivers, and we want to take it out of your hands.
Yeah. So when I'm looking forward to the day when I can just use your tool to set up everything on my Windows machine and not worry about anything.
Yeah, I'm looking for this day too. Yeah. So if I just may add, as I said, GN is an open source tool. It's 100% open source, and it's backed by the community. If you want, you can go to gn.dev. You can put your mail here and add it, and it will be added to the mailing list. You can see here the integrations. And if you go here, we also have a documentation site which explains how to install in every kind of flavor of the installation, how to use it, how to configure an environment, what happens if you run anything, how to attach to devices. We also documented advanced usage like running from multiple terminals, using sudo commands, running containers, etc. And we also have a Slack community. If you will go to the gn.dev, you will see this Slack community button. And this is the Slack community where we announce new features. People can ask for help, submit issues, discuss about new features and something that works for them and something that doesn't work for them. And we are really looking for our first major user base. So if you're a GPU user, I totally recommend you to go check it out, and maybe it can be useful for you as well. And feel free to just drop an issue on GitHub or anything, because we will be communicating and responding. So
Nice choice of Slack communities that I see on your left. Do you have any advice for anyone who is watching this?
Yeah. So after dealing with GPU resources for quite a few years now, I think that on one hand, many people want to stop caring about these things, right? And the world is not there yet. And I think that the only way that we will get there is when GPU resources will not be managed as an afterthought. I think that projects, while building a project, while developing a model, you need to put attention to what GPU resources do you need, how much resources do you use. You need to document them using GN, for example, and they need to be part of the project, because this is the only way when people when they start to use another project, or maybe even their older project, this is the only way that we can eliminate this step of configuring the environment and making sure that all the prerequisites are settled. And I really believe that GPU users should start thinking about a bit more about these GPU resources. Just once, document them, and then you can forget about them. And this is the holy grail. We want to forget about them. We just want them to be there when we need them. And that's all, right?
Yeah, great advice. Thanks a lot for the demo and
Sure.
great tool. Thanks for putting this together and thanks for making it open source.
Thank you. Thank you very much. It was a pleasure being here. Looking forward to see other tools in the future.